All right, so we're going to look at in this video is annuities, okay? So the word annuity maybe has a couple of different meanings. What we are talking about on our course when we say annuity is a financial product where you buy an annuity with a big lump sum of money and then you receive payments out of that annuity into the future, a series of payments. So like there's a big outflow of cash from you to purchase the annuity, but then there is a series of monthly or annual flows from the annuity to you. They're often used as a way of structuring pensions. So when you retire, you purchase an annuity with a big lump sum of money you've saved up, and then throughout your retirement you receive every month or every year, usually every month I would say in reality, your pension payment out of this annuity. Okay, like the way the maybe exam or book makes it seem is, you know, throughout your working life you're saving lots and lots of money, and then on retirement you purchase an annuity yourself and it is funding your pension. Then in reality probably throughout your working life you're making pension contributions to some pension company. When you retire they will purchase that annuity for you and then you will receive those pension payments out of the annuity. Okay, but the main thing I would say is at a certain date there is an outflow of a big lump sum of cash from you, and then in the future you receive inflows of a series of fixed payments. Okay, so I've got an example here which I will work through now. So you want to receive a payment of €15,000 at the start of each year for 20 years beginning on your 68th birthday. How much would it cost to purchase this annuity assuming a 3% annual interest rate? So how much would it cost to buy the annuity that's going to give you 15 grand a year for 20 years? Okay, so what we are looking at is how much is this annuity going to cost that on our 68th birthday it pays us €15,000, and then in 1 year's time it's going to pay us €15,000, but 15,000 in a year's time isn't worth 15,000 today. We'll think of today as being your 68th birthday, so we need to discount that 15,000 by 3%. And then in another year's time, I'm going to receive another 15,000. And that's going to be discounted twice. Okay. All the way until at the start of the 20th year. So at the start of each year for 20 years, beginning on your 68th birthday, you're going to receive a 15,000 payment from this annuity. And just be careful here, so the first one isn't discounted at all, the second one is discounted once, discounted twice, the third one. So this 20th payment, because you're receiving at the start of the 20th year, is only going to be discounted 19 times, not 20 times. Okay, so I would assume these are being received at the start of each year if a question doesn't say, but just pay attention to if it says it's received at the end of the year maybe. Okay, so if you look at this now, so it's 15,000 plus 15,000 over 1.03 plus 15,000 over 1.03 squared. We've got a geometric series like we've seen elsewhere. We've seen these maybe when we were looking at mortgages, and looking at mortgages as a series, and also when we were doing a series of investments. Okay, and actually you'll see it looks exactly like when we do a mortgage as a series. Okay, and in a way you can think of annuities nearly as being a mortgage in reverse. Okay, like in a mortgage you borrow a big lump sum of money, you get a big lump sum of money, and then you are repaying it for a number of years. With this, you buy an annuity, it's a big outflow of cash for you, and then an inflow for a number of years. Because of that, you will see these done using the amortization formula. I prefer to do these annuities using the series formula, and just leave the amortization ones for mortgages, but you will see it done that way. So looking at this series here, it starts straight away. So my first term is 15,000. And then what's my OR? What am I multiplying by to go from term to term? I'm multiplying by 1 over 1.03. Okay, so I've got a geometric series with a first term of 15,000 and an OR of 1.03. So I'll just plug those into the geometric series formula. So it's S20. Well, I'll just put the formula in. So Sn equals A on 1 minus OR to the N over 1 minus OR. So even though this stops discounting 19 times because you're receiving at the start, there is going to be 20 terms here because this is it not being discounted at all. So there's 20 terms here. So it's S20 I'm looking for. Is equal to A, my first term, so that's 15,000 on 1 minus OR. Here is, sorry, my OR is 1 over 1.03. The 1.03 is increasing at the bottom of the fraction, so 1 over 1.03 to the power of 20, all over 1 minus OR. So all over 1 minus 1 over 1.03. Okay, so just plug that in and it will tell you how much that annuity will cost you. So 15,000 multiplied by 1 minus 1 over 1.03 to the 20 divided by 1 minus 1 over 1.03. And they're saying 229856. And 99 cents. So they'll probably question on something like this, they'll probably say round to the nearest euro, so 229857 maybe, okay? So 229,857 euro to purchase a product that will pay you 15,000 a year for 20 years, okay? What's the kind of common sense check I can do on the answer? Well, 15,000 multiplied by 20 is 300,000 euro. But I'm discounting a lot of those flows, so it will cost less than 300,000 euro. Okay, so that's part one. That's how to work out how much it will cost to purchase an annuity, paying a certain fixed payment in this case every year. As I said, in reality it's more like every month, but questions will have both. Okay, so I'll finish off the part 2 and 3 in a separate video.